time is gold. So you really need to charge as fast as possible. And for these use cases, AC charging does not really meet the demands of power, and is when the fast DC charging comes into play. When we refer to the term of megawatt charging, this is just the power conversion that happens when you go from AC current to DC current. Forget about which vehicle you're putting that power. So megawatt charging is the power conversion of at least 1 megawatt.
This is the Podcast for Engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. Today we're going to be talking about megawatt charging, and I'm joined by my colleague, Rodrigo Marquina, who is the Global Application Manager for EV Charging at Infineon. Rodrigo, thank you so much for being here.
Thank you very much, Kelsey, for having me here. Very excited.
Yeah, I always love talking about EV charging, but it's been a while since we've had an EV charging focused topic on the podcast. So I'm excited to take it back to basics. When we're talking about EV charging, we hear a lot about AC charging and DC charging. What's the difference?
Well, that's, I think, the most fundamental difference between how you charge your electric vehicle. The most simple one is the AC charging, which basically just take the current from the grid. Of course, you need to do some metering, and then you put it inside the car. While the DC charging, or fast DC charging, this is where you need to do the power conversion and converting the AC current to DC current, and then you can skip the OBC inside the car or the onboard charging inside the car, and then you can directly connect the power into the car's battery management system.
Okay, so DC charging seems like the name, more direct without the OBC. Are there any particular use cases where you would use DC over AC?
Yes, so normally, let's say, you can use AC and DC charging in nearly all type of use cases. But traditionally, or due to the complexity, if you think about some residential EV charging, then it's easier, the installation of an AC charging. And typically at home, you can have your car plugged in the whole night. So you don't need that much power to charge your car. Whilst if you are on the street, if you are in a shopping mall, or even more in the highway, then time is gold. So you really need to charge as fast as possible. And for these use cases, AC charging does not really meet the demands of power, and is when the fast DC charging comes into play.
Okay, so most EV chargers probably have AC charging options at home, or maybe even at work when they have a lot of time to spare to wait for their car. But when it needs to happen fast, you say DC charging is the way to go.
Yes, correctly.
Okay, well, I mentioned at the beginning we want to talk about megawatt charging. So is megawatt charging DC charging?
Yes, so when we talk about megawatt charging, we are directly speaking about DC charging, simply because with AC we cannot reach that amount of power. So megawatt charging is definitely DC charging only.
Okay, so what is megawatt charging?
So megawatt charging, when we refer to the term of megawatt charging, this is just the power conversion that happens when you go from AC current to DC current. Forget about which vehicle you're putting that power. So megawatt charging is the power conversion of at least 1 megawatt. And then how you distribute this power, then we can start going into the specific use cases. But we talk only about the power conversion.
Okay, yeah, because when I think about a whole megawatt of power that you're able to charge something, I imagine a giant charging station. Is that really the reality?
It is definitely bigger than the standard AC wall box that you would have at home, simply because you need all the power elements to transform, to convert the energy and the current with the cooling systems and so on. But the principal thing here is not about the size. It's about how you can make more efficient the transmission of power from the grid at the end to the final vehicle. And when you're talking about megawatts or in the range of megawatt, then the DC charging, it gives you a much higher efficiency of power per square meter than AC. Yeah.
So when I'm thinking about megawatt charging solutions, is it just for a single truck then? You mentioned it could be different types of vehicles, but a big truck might need more power.
I think most of the people, when they think about megawatt charging, they associate the term only with electric trucks. And this is definitely one of the most important use cases. If you think about a long-haul truck that's transporting certain goods from one country to another one that needs to drive hundreds of kilometers in one day, you need to make this trip as efficient as possible in the shortest amount of time. And these trucks, they have very big batteries, right? So you need a lot of power on the highway to refill the batteries as fast as possible. And for these ones, if you can pump in 1 megawatt into the truck, then this will shorten your charging time. However, it's not specific to a vehicle. You will have certain cases where the same megawatt charging can be addressed into different vehicles. And this is what we call a dispenser solution.
Okay, so it's not just one big charger, one big plug, and one big vehicle. It can be distributed.
Correctly. So here we talk about two different type of solutions, what we have or what we see in the EV charging area. What we call the all-in-one charging solution is where you have your power conversion and you are delivering the output to one, sometimes two vehicles. What we call a dispenser solution, this is where we are talking already in the megawatt area, or 2 megawatt, 3 megawatts or above, where you have decoupled the power conversion to the output, so where you actually connect the car. And in this case, you will have a centralized power conversion unit of 1, 2 or more megawatts. And then this centralized power conversion unit will distribute the power to all the outputs. And these output units is what we call the dispensers.
Okay, so one big cabinet dispensing to these little dispensers.
Correctly.
Okay, does that mean that a truck can charge at the same time as then another car?
Yes. So let's pretend you have your main power conversion unit of 1 megawatt. And you have 4 different dispensers. If you have only one truck coming to your station, then you can direct the entire megawatt of power to that truck.
I'm sure he'll appreciate that.
Definitely, yes. But it could be also that the truck is nearly fully, the battery is nearly full. So they won't need the 1 megawatt. So you can address less power to this truck, and then you can still have some power available for other vehicles that will come to the other output units or the dispensers. So this gives you a lot of flexibility on how you distribute the power among all your dispenser units.
Okay. So you mentioned megawatt charging. Are there any standardization? Is there any standardization happening in megawatt charging already? Because I know for a regular electric vehicle charging, there are some organizations already making standards.
Yes. So as we know the charging areas as of today, here in Europe we have the CCS, which combines the AC and DC charging capabilities. In North America they have the NACS. In China they have their own. In Japan they have their own. And for megawatt charging, what it seems that is being consolidating in several regions is what we call the megawatt charging system, or MCS for short. And this is a standard proposed by CHARIN, CHARIN being the Charging Interface Initiative, which basically established the standard on how these chargers or the protocols, how they're going to communicate with the vehicle and how the charging plugs look like, so that there's compatibility among all chargers and vehicles.
Okay, so we don't have to have a different charging cable for every car or every
That is the point. Now for the cars, depending on the region, you will have different chargers or the plugs. The idea is that for trucks, since they are more prone to go to different regions, to different countries, that they won't have problems to find a charger that fits their their socket.
Oh yeah, everyone hates buying an adapter when they're traveling, right? For your razor or something.
And this would be possible, but this brings some other complications on reliability and so on.
Okay, but good to know that someone's working on it. And megawatt charging is a relatively new term to me. I don't remember talking about it a few years ago. So this is a fast evolving industry, right? Where do you see things what will we be talking about in the next 2 to 3 years or even 5 years?
Yeah, well, I would say even starting from this year and from next year and the next 3-5 years, we see a very much increase or a very defined trend on the electrification of the transport system. So I'm not talking about the passenger vehicles. I'm talking about the electric trucks moving goods from one country to another one. I'm talking about the long distance buses. So all of this type of transportation is also being electrified at the moment. And the megawatt charging is definitely the main use case for these ones. And the other part being that when you have the charging stations and you need a lot of different outputs to serve different vehicles, so cars or trucks, doesn't matter, then you need a megawatt charging centralized unit that can serve all of these ones instead of having dedicated power conversion at every charging pile.
Okay, so that's another argument for this dispenser solution, right?
Definitely. If you think about from the point of view of the charging point operator, which at the end is the owner of the charging station serving the vehicles, they have quite often also limited space to work, right? And all the electrical installation is rather expensive. So if you could minimize the cost of the high power installation, then they can increase their profits, of course.
Okay, makes a lot of sense. And we were just talking about the different cables and standardization. I just was thinking about, my phone and how we've gone from different versions of USB over the years. And now we're at the great enabler wireless charging. Are we ever going to be able to wirelessly charge?
You mentioned it because, even now there's a lot of concepts. There's already some trials in real world where we are talking about wireless power transfer, how we call it.
Okay, so inductive charging.
It's inductive charging. Yeah. It works in principle the same as your phone. You need one coil on one side and then one coil on your phone, or in this case in your car. And then you can make this transfer energy without having direct contact. And this, as of today, is a very niche application. But in the future, this might have more relevance if we think about taxi stands, for example, where you don't have really the time much of going out of the car, plugging in, plugging out, or even more, looking at the future with the whole autonomous driving. If you have a car driving by itself, who will plug in and plug out the car? So it's way easier that the car park exactly where it should so that it can charge as fast as possible.
Okay. Well, lots of different things happening in the space. I love talking about EV charging because every time I talk about it, it seems like there's some new use case coming out. So thank you so much, Rodrigo, for being here and talking about megawatt charging.
Thank you very much, Kelsey. And if you have any other questions, don't forget to visit our website.
Yeah, will do. Thank you. And I'll, of course, link our website in the description below for all of you listening. And if you're interested in EV charging or megawatt charging, please do check it out. We have a lot of different resources available there. And please stay tuned for more episodes. Thanks.